All right, so we're going to go and get started. This section is 4.3. So 4.3, it is called proportions. All right, so a proportion is basically a fancy name for a fraction, okay? The technical definition of a proportion is a fraction of a whole or a part of a whole, all right? So the best way to look at this is just by examples. So I'm just going to give you guys a whole lot of examples, and that hopefully will help clarify what a proportion is. Like I said, it's basically a fraction, so I'm basically just going to be showing you how to solve word problems, okay? All right, so but before we can start, we need to know how to convert from a fraction to a percentage and from a percentage to a fraction, okay? All right, so convert from a fraction to a percentage. All right, so the problem we have is Todd ate 3/5 of the pizza. What percentage of the pizza did he eat? All right, so in order to convert from a fraction to a percentage, you basically do it with your calculator, all right? So if you don't have a calculator, you can do these in your phone as well, but you put in your calculator 3 divided by 5. When you do that, you're going to get 0.6. Once you get the decimal value, you take this decimal value and you multiply it by 100. So 0.60 times 100 is 60%. So I can write steps here if you'd like them. 1, divide fraction. 2, multiply result by 100. That goes you from a fraction to a percentage. All right, any questions about how to go from a fraction to a percentage? Good? All right. Now we're going to go the other way. We're going to go from a percentage to a fraction. From percentage to a fraction. All right, so here we have, if Todd ate 32% of the pizza, what fraction of the pizza did he eat? All right, so when you need to go from percent to fraction, all you do is take your percent and divide it by 100. So as a fraction, 32% is the same thing as 32 over 100. All you have to do is take your percent, put it over 100. Sometimes when you're reading it, they will go ahead and reduce the fractions. All right, so this is the same type of reducing that you might have seen in previous math classes. So I'll do a real quick, strange, wasn't it? Okay. Oh, okay. we all looked and were like, okay, maybe I should close the door and lock it. All right. So what you can do to reduce it is you can say, what's the highest number that 32 and 100 can be divided by? All right. So the highest number I can think of is 4. So 32 divided by 4 is 8. And 100 divided by 4 is 25. For this class, you do not have to reduce, but if you are planning on being an elementary school teacher, this is a core concept they teach in math, and it's also a core concept you will have to know for your OGET. All right? So if you don't, or if you are uncomfortable reducing fractions and you need practice, all you need to do is Google reducing fractions help, or I would say worksheet, or you could say teaching, something like that, okay? They have great resources, and I definitely encourage you to do that. All right, so now we have went from 32% to 8/25. We went from percent to fraction. Any questions about how I went from percent to fraction? We're good? Okay. All right. Let me erase this. Okay, so now we're going to get into the problems like what are on your bingo sheet, which let me give you one, Rebecca, so you can know what we're talking about. There you go. All right. So let's look at this example. If there are 38 students, in a class, and 21 of them are male, what proportion of them are not male? This exact question is not on your question sheet, it's just similar to one that's on there. The reason I phrased it as what proportion of them are not male versus what proportion of them are female is because for some reason in math textbooks, I've noticed they like to phrase it like this. I honestly think it's them attempting to make it more difficult than it has to be, but since I don't write the curriculum, I just teach it, I'm just trying to prepare you for the wording that they use, okay? All right, so proportion, like I mentioned earlier, is basically a fraction. So when they ask what proportion of them are not male, what we want to do is we want to take the number of females and we want to put it over the total number of students. If the word proportion throws you off, you could also read it as what fraction of them are not male. All right, so Chance, if 38 students are in a class and 21 of them are male, can you tell me how many are females? You did tell me you'd slept, so 17, very good. You did sleep. Look at that. All right, so 17 over the total number of students. So our proportion or fraction of our students that are not male is 17 over 38.
That's the final one.
And this is your final answer. I need to turn this a little bit. I'm cutting off. Rebecca, you look inquisitive. Are you just reading it or do you have a question?
I'm just reading it.
Okay. Okay, so this is your final answer here, 17 out of 38. Rachel, have a question? She was a little confused.
I was just looking at how to do that.
Okay, all right, so you're good, you understand? Okay, all right. Okay, so let's move on to the next one here. All right, so the next example we're going to look at, example 4 technically is what I have here. 245 is 60% of what number? So a way to look at this, like in a real world situation, would be, say someone bought a coat and you said, how much did your coat cost? And I said, $245. Well, if it's for me, it would be a lot, but let's say this person's uber rich and I think that's super cheap, okay? So then they say, oh, well, I got it on sale. So $245 was only 60% of the original price, which would make it how much of a discount? Can you guys tell me? 40%, right? So if it's 60% of the original price, then that means it was a 40% discount. But that's not part of the problem. That's just a side note, okay? All right, so here we want to find what number, if you take 60% of it, gives you 245. So I'm going to write that out just for teaching purposes. What number, when you take 60% of it, should be 60, I'm gonna move down here, is 245. This is what we're trying to figure out. The best way to do this is to set up an algebra equation, okay? I knew you were going to give me that face. It's the conversations we've had in the past, all right? But I'm going to show you exactly how to do it, okay? All right. We don't know what our original number is, right? That's because we're trying to find what number. So we're going to call this number here, we're going to call it x, because we don't know what it is. But what we do know is that 60% of x is 245. All right, so now that we have this, the first thing you need to do is convert 60% to a decimal. The first step here. So to convert it to a decimal, you take 60 and you divide it by 100 in your calculator, and that's going to give you 0.60, okay? One of the gentlemen in my stats class, he always talks about how when you need to convert from a percent to a decimal, you write it out with your decimal there, and then you move it 2 spots to the left. So if you can remember the fact that when you convert from a percent to a decimal, that you move the decimal 2 spots to the left, this just makes it easier than always having to type your percent divided by 100 in your calculator. All right, so 2. Once you have your percent in decimal form, you take X and multiply it by 0.6, or I should put by that decimal, since these are directions and not example specific, and set it equal to the number. Okay, so what that looks like, I'm gonna erase this and put it up here. What that looks like is X times 0.60 equals 245. You take your variable, which is that X, that unknown, you multiply it by the decimal form of the percentage, and that equals the number that you started out with there. All right, once you get to this point, so this would be step, that way, okay. This would be step 3. Divide both sides by the decimal number. So we have X times 0.60 equals 245. I'm going to divide this side by 0.60 and that side by 0.60. When I do that, this 0.60 and that 0.60, they cancel and go away. So you get X equals 408.33. We're going to do another example like that. So if your mind was a little tried by that example, we're going to do another one. But I am going to have to wing it. All right, so I'm going to erase this and we're going to do another one as far as, does everyone have this written down that wants it? If not, I can pause and hold on. Okay, all right, let's do another one here. And I'm just going to erase. Just going to leave all this up here. All the directions. Okay. So 15 is 35% of what number? Exactly the same, it's different numbers. All right, the first thing we want to do is convert 35% to a decimal. So Amanda, I'll start with you. I already did chance, so I'll start with you. How do I convert 35% to a decimal?
Put it over 100.
Mm-hmm, yep. And if you put that in your calculator, what do you get for a decimal? 0.35. 0.35, there you go. You just want to jump in there so I can skip you for the next hard step, right? All right, Rebecca. Sorry that Taylor kind of, you know. All right. Can you tell me, based on these directions, 0.35 and the number 15, how would I set up this equation? 15, perfect. There we go. X times 35 equals 15. Okay? All right, so then number 3, divide both sides by the decimal number. All right, so Rachel, if we divide both sides by the decimal, what would I divide by?
0.35.
Mm-hmm. Yep. All right, that's perfect. So we're going to divide both sides by 0.35. And if someone could tell me what that is, please, I would appreciate it. 42.86. So that means all right, now we're going to work it backwards. Okay? All right, everybody get this written down that wants it, and then we're going to go backwards. You're done writing, or you're like, I'm done with the day?
Well,
You can't be done with the day yet. You got to prepare your bingo card. All right, okay. So erase this because we're just going to keep the answer and the original question. Okay. All right. So we said that 15 is 35% of 4286. Okay. So 42.86. And someone put 42.86 times 0.35 in their calculator. It's 15. Yep. All right, so you see how that works? So 15 is 35% of 42.86. So if I say, what is, so if I was to change the question and say, what is 35% of 42.86? What I do is I take 42.86, multiply it by the decimal form of our percentage, and that gives me 15. Okay, so you would take 42.86, multiply by 0.35, and that gives you 15, which is good, because if it didn't, there'd be a problem. All right, okay, so we're going to look at some more. Example. 25% of 25 is what number? I'm going to draw a box up here. All right, I want to show you the difference in how these problems are worded. These are the ones we just solved with the algebra equation. 245 is 60% of what number? So we have number, then percent. If you have number, then percent, the algebra. If you are given percent and then number, all you have to do, so if you have percent, then a number, 1, convert percent to decimal, which we already talked about how to do that. And then multiply the decimal form of the percent by the number given. All right, so Lisa, we're to you. If we were to take and multiply the decimal form of the percent by the number given, what expression would we have?
0.25 times 25.
Perfect, yes. 0.25 times 25. 0.25 times 25. And if someone could be as kind, because I did make this one up, 6.25, thank you. So obviously it is much preferable to have a percent and then a number, because obviously this process is much shorter, but there are a mixture of both. But maybe you got lucky, because I did use a random number generator to make your bingo cards, so some of you might not have any like this. So don't be gloating to the students that do, okay? All right, okay, so let's look at another example here, or I should stop. Any questions about this one? You good? Okay. All right. Here. All right. Suppose that 12% of students chose to study algebra.
Okay, if I go to the bathroom real quick.
Oh yeah, go ahead. And that meant that there were 12 such students. How many students chose not to take algebra? Here, step back, I'll let you guys get that written down. This is like number 10. So if you have number 10 on your bingo card. All right, okay, so this is what we gotta do for this one. I'm gonna label steps on this one as well. Okay, so all we know is that 12% of students chose to study algebra, and that of the total student population that could have chose algebra, 12% equaled 12 students, all right? So 12% of the student population is equal to 12 students. So we know that. Unfortunately, what we don't know is how many students there are overall. So total students is a mystery. All right, so before we can figure out how many students chose not to take algebra, we have to figure out how many students even have that option. Because you can't say, okay, well, 12 took algebra, so the rest didn't, right? We know that. So say in this class that 2 of you chose to take algebra. Then we could obviously say that 1, 2, 3, the other 4 of you didn't. So 2 chose to take algebra, 4 didn't. But here, all we have is 12, and we don't know how many are left, okay? So in order to find the total students, this is the exact same problem, just in word form, of that 245 is 60% of what? It is solved the exact same way. So here, what is our number that they give us? 12, right? So I can write this as 12 is, and what percent did they give us? 12%. So 12 is 12% of what number? This is the story problem, or the real life problem. This is the math problem. The key to solving word problems is being able to take all the wordiness and simplify it down to what you really need. All right, so now we're going to solve this just like the other. So the first thing we want to do is convert our percent to decimal, and we are at U, Summer. Be 0.12. So you can do 12 divided by 100 in your calculator, or you can just move the decimal over 2 places. So 0.12 is percent in decimal form. All right, the next thing is setting up our equation. So I'm sorry, Chance, but by fairness, we are back to you.
Equals 12.
Yeah, but that's the third step. So you're helping Amanda out there. Yes, this is correct. So X is the total number of students, because that's what we don't know. 12% is what we're told, and we're told that 12% of the total students is 12 students. All right. Now, Amanda, what should we do next?
Divide both sides
Divide both sides by what?
by 0.12.
By 0.12.
That one's gonna cancel out.
Exactly. So X 12 divided by 0.12, you can put that in your calculator. It comes out to be 100. All right, so now that we know our total student population is 100, I can put that here. If we have 100 students, 12 took algebra, how many did not take algebra? What did you get, Taylor?
88.
88, that's right. And how did you get that? You're like, I magically swiped my calculator and it appeared.
Minus 12.
Exactly. So we took the total number of students minus the number of students that took algebra. So I'll label this here for any of you guys that want to watch the video later. Total students minus students who took algebra. So 100 minus 12 equals 88 students that didn't take algebra. Let me see if I missed any. Nope. Okay. So that is all the examples that I have. So Rebecca, so you didn't hear the directions, so I'm going to tell you the numbers that are on your bingo card. Those are the number problems that you do on here. This is going to be your homework for this section. So write out all the steps and everything and write the final answer, and you'll turn that in on Tuesday. And you put the answers in that spot on your bingo card, and we'll play bingo on Tuesday after the lesson. And I will give the correct answers on Tuesday for you to make sure your bingo card's filled out correctly. And so you guys can work by yourselves in here, you can work in groups in here, and I will just come around and help you if you need help. So just go ahead and get started, and if you get stuck, let me know. And I'm going to fill out a bingo card because I'm going to play too. Do you want one, Karen? But yeah, for sure. If anybody, if you get stuck, let me know and I'll come around. When I told my mother about this activity, she's like, I like it, but I liked trash get ball better. I was like, thanks, Mom. She told me I couldn't live up to trash get ball. I was like, really, thanks. Oh, yes. The very first example.
But there's only 2.
So it says here 2 out of 10 didn't have track. Okay. So it's 2 out of 10 didn't have track. 8 over the fraction. So 8 out of how many? 10. Yep. 8 out of 10 kids. Yeah. That's it. In that and in the 3 homework. But make sure that I have 1 next to so I'm grading it for homework alone, or 3 next to it. So I'll know which one it is. Yeah. Please remember when you're working out the problems, put the problem number next to it, because when you turn it, I'll have to be able to grade it. So I'll have to know which problem I'm grading. Okay.
was what is the ratio of people who carry the gene to the people who do not carry it? And we said 2 out of 7 carry it. So how many do not carry it? Okay, so if I have a ratio of those who do carry it, to those who don't. Maybe I'll say, oh, she's like, that's all you want me to do?
You basically just go through and decide if it's algebra or not.
Oh, no, you have to solve it.
Well, yeah, I know.
Yeah, okay, yes.